Hello students, I am Dr. Amit Bhatnagar, working as Senior Research Officer in the Department of Agronomy at GB Pant University of Agriculture and Technology, Pantnagar, Uttarakhand. Here, some reasonings are related to solar radiation, and this is reasoning based lecture we can say, and this is very helpful for reason and assertion type question. So these reasons are very scientific and logic based, so we will discuss about these reasons which are related to solar radiation. So please watch the lecture which is already uploaded on different form of solar radiation. What is solar radiation and what are the different form like direct solar radiation, net solar radiation, reflected, scattered, etc. Then this lecture will be helpful. So if we talk about the reasoning, so the sun emit electromagnetic radiation, but most of the radiation is in the short wave length, while when earth emit the radiation, then this radiation is long wave. So what is the reason that the radiation emitted by the sun is in short wave length and radiation emitted by the earth is in long wave radiation? So this long wave radiation is infrared region and short wave radiation in the range of ultraviolet and visible light. So actually this radiation is emitted by the body when it is heated and has temperature. So as the temperature increases, then heat is emitted in the form of radiation. So when a body get temperature, then it start to emit the radiation. As the temperature increases, the amount of radiation also increases, but the quality or the wavelength is different. So according to Wien law, Wien was scientist, and according to him, Wien law, as the temperature increases, the wavelength decreases. So there is a inverse relationship between the wavelength. Wavelength is denoted by lambda. Lambda is inversely related with the temperature. So if body has high temperature, like sun, then it emit the short wave radiation, and if temperature is low, then it will emit long wave radiation in the range of infrared. So as compared to the sun, earth temperature is very low. At the outer surface, temperature of the sun is about 6000 Kelvin, and at the earth it is generally about the 20 degree centigrade or 25 degree centigrade, hardly 40 degree centigrade. So earth when emit the radiation, when it get the heat by the solar radiation, then it start to emit the radiation, and this radiation is inversely related with the temperature. So temperature of the earth is low, that's why wavelength is more. That's why the earth radiation is long wave radiation, that is infrared region. So this is the reason that short wave radiation, major part is of short wave radiation, and in case of earth, major part is long wave radiation. So as the temperature increases, the wavelength decreases. So this is the reason that earth emit long wave radiation, and the law is Wien's law, Wien's displacement law. It is related with the wavelength and the temperature, and the relationship is inverse. So please note down that this relationship is inverse, and here lambda is wavelength. Another reasoning is scattering of short wave radiation occur. So when radiation move or from sun to earth, when radiation enter into the earth atmosphere, then particles are there, pollutants are there, small dust particles are there, and because of this particles, scattering occur. There is no reflection. Actually scattering is different from reflection. In case of scattering, when it hit the particle, it move in all direction. So, and this scattering is more common in short wave radiation. Suppose this is the radiation and it hit the particle, dust particle, then it radiation move to all direction. That is known as scattering, and it is different from reflection. In case of reflection, suppose this is the radiation and they hit the particle, then back into the direction. So this is the difference between scattering and reflection. So this Scattering of short wave radiation is very common. So when radiation move into the atmosphere, then short wave radiation is scattered by the particles. But long wave radiation is not scattered. Long wave radiation is absorbed. It is not scattered. So what is the reason that only short wave radiation is scattered, not long wave radiation? Actually, this scattering phenomena was described by a scientist Rayleigh, 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 and according to Rayleigh, the scattering occur by the particles if the particle size is less than 1/10 of the wavelength. So if size of the particle, dust particles or any pollutant is 1/10 of the wavelength, 1/10 of wavelength, then these particles cause the scattering. So it means scattering caused by very small particles, not by the large particles, particularly those particles which size is 1/10 of wavelength. Okay, so it means large particles are not involved in scattering, only small particles. But the question is why there is only a short wave radiation. So he observed that this scattering is inversely related with the wavelength, and inverse relationship with the fourth power of wavelength. Suppose wavelength is lambda, so it is inverse relationship of fourth power of lambda. It means scattering, we can say it is scattering is inversely related with the fourth power of wavelength. So if wavelength is more, then scattering will be less, and if wavelength is less, then scattering will be high. And UV rays in the range of 0.3 or nano, in case of nanometer it is about 300 to 400 nanometer, and visible light, that is known as PAR, photosynthetically active radiation, PAR, Bivgyor, 7 colors: violet, indigo, blue, green, yellow, orange, red, that is known as PAR, and it is in the range of 400 to 700 nanometer. And infrared, it is about more than 700 to 4000 nanometer. So these are actually the short wave radiation, and infrared is long wave radiation. So it means there is more scattering of ultraviolet and PAR. And if we talk about the PAR, Bivgyor, violet, indigo, blue, green, yellow, orange, and red. So red has 700 nanometer, and this blue is about blue, violet 400 nanometer. So among these 7 colors, the less wavelength is of blue light, so that's why there is a more scattering of blue light as compared to red light. So there is more scattering of blue light. And if we talk about the long wave and short wave radiation, then more scattering of short wave radiation, because they hit the particles and they scattered, they disperse in all direction. And this scattering is known as Rayleigh scattering. Rayleigh scattering. So this was the reason that short wave radiation is scattered by the particles. Then next is diffused radiation is more effective for plants. So diffused radiation effective for plants. So what is the diffused radiation? Diffused radiation is that radiation which reach on the earth, on the substance, by the scattering. Suppose a radiation is there and it reach on the object, it is directly reaching, it is known as direct radiation. And suppose radiation is there and it is hit by the particles, small particles, scattering is there, and it is reaching on the substance, then this radiation is known as diffused radiation. And diffused radiation is very important and effective for plants. So what is the reason? So the reason is that actually diffusion is due to scattering, and scattering is of short wave radiation, and short wave radiation is UV radiation and PAR radiation. So it means the radiation which is diffused radiation means actually which is scattered. So scattering of PAR, it means the PAR radiation is reaching more, ultraviolet reaching more, PAR is reaching more on the plant. So definitely there will be more photosynthesis. So in direct solar radiation, if we talk about the content in direct and diffuse radiation, direct and diffused, and the content of UV radiation and PAR, and third one is infrared. So in direct solar radiation, UV is about 2% and PAR is about 42%, and now you can calculate it is about 56%. But diffuse radiation, there is a more scattering of short wave radiation. So it means diffuse radiation has more ultraviolet, and PAR means photosynthetically active radiation, that is visible light, and this visible light means PAR is responsible for photosynthesis. So amount increases. So PAR is about 65% and diffuse radiation it is about 10%, and it is about 25%. So this is the reason that diffuse radiation, there is a more amount of photosynthetically active radiation. What is photosynthetically active radiation? Which is involved in photosynthesis, and this is actually visible light. Visible light in the range of 400 to 700 nanometer. So out of ultraviolet, PAR and infrared, only PAR is involved in photosynthesis. So this is the reason that in diffuse light there is more content of PAR. That's why effective for plants. Another reason is that suppose a plant is there, crop is there in the field, and direct radiation is on the top canopy, but lower leaves there is no direct solar radiation, and the radiation which is diffused, that is scattered, reach into the lower canopy. So availability of radiation to lower leaves is only due to diffuse radiation. So diffuse radiation is responsible for photosynthesis, not the direct solar radiation, because direct solar radiation is on the top. So because of these two reasons, number one, more PAR content, more amount of photosynthetically active radiation, number one. Number two, more availability of diffuse radiation, because diffuse radiation reach in all direction, while direct solar radiation reach on the top of the canopy. So lower leaves get the light from the diffuse radiation and make the photosynthesis. So this is the reason that diffuse radiation is effective for plants. Then another reasoning is ultraviolet radiation is harmful. As we see that in direct radiation 2% is UV and 10% is diffuse radiation, and more content of ultraviolet. So this ultraviolet, high ultraviolet content is dangerous, it is harmful, and ozone in the atmosphere is responsible for filtration of ultraviolet. Actually ozone gas, O3 gas in stratosphere absorbs the ultraviolet radiation, and it reduces the amount of ultraviolet on Earth's surface. Otherwise, if there is less ozone content, then ultraviolet radiation will reach more on the Earth, and it will cause harmful effect. So why ultraviolet radiation is harmful? The reason is that actually radiation, electromagnetic radiation, solar radiation, whatever radiation is there, and this radiation actually consists of very small particles, we can say, and these particles are massless, we can say, and these particles are known as photon. So radiation is emitted in the form of photon, and these photon carry energy, and energy of photon, every photon is calculated as E is equal to h mu or h c upon lambda, where mu is frequency of the light, or we can say hc is speed of light and h is wavelength. So we can see that energy of photon is directly related with the frequency mu, it is known as frequency, or energy is inversely related with the lambda. Actually frequency and lambda are inversely related, and h is Planck constant. H is Planck constant, and its value is 6.6 into 10 to power minus 34 joule second. So it means the energy of photon, of any radiation will be decided by its frequency or wavelength. If frequency is more, definitely energy will be more. If wavelength is low, then energy will be high. So as we know that ultraviolet is in the range of 300 to 400 nanometer. It is the lambda, and PAR is in the range of 400 to 700 nanometer, and infrared is more than 700 to about 4000 nanometer. So here ultraviolet has less lambda. So lambda is less and it is inversely related with the energy. So lambda is less, so energy is high. So it means energy of UV is more, followed by PAR, followed by infrared. So it means the UV light has maximum energy, followed by PAR, and the least energy in infrared. So because of this reason, because energy is decided by E is equal to H mu. This is very important formula, and H is Planck constant. So mu is frequency, or we can say frequency of UV is high because lambda is low. So energy of UV light is more, and energy of infrared is very less. So infrared is not harmful. Visible light is not harmful because energy is not so high, but UV light has more energy because of this formula. Frequency is very high of ultraviolet radiation, and we should know that frequency and wavelength are inversely related. So this is wavelength. Wavelength is low, frequency is high, and frequency is high, so energy is more. So because of this high energy, UV light is dangerous. So high content of this UV light is also harmful for the animal, plant and human. So ultraviolet radiation is filtered by ozone. So this is the nature control that it absorbs the ultraviolet, and very less amount of ultraviolet reach on the earth. If ozone is depleted, then more ultraviolet radiation will reach on the earth, and it will cause the harmful effect on all the living organisms. Then another question related with the albedo, and snow and ice have high albedo. So first of all, we should know what is the albedo. Albedo is known as reflected radiation. Suppose this is radiation and it is reflected back by a substance. This is the incident radiation and this is the reflected radiation. How much amount is reflected, that is known as albedo. So albedo is the ratio of reflected radiation to incident radiation. So snow and ice have high albedo, means more reflection. Actually, when incident radiation is there, then some radiation is absorbed, some is transmitted, and some is reflected, and some may be scattered. So these may be different fate of radiation. So if surface is smooth, shine, white, like this blackboard, this board, no, sorry, whiteboard, then reflection will be high. So ice and snow are white, shiny, and very smooth. So that's why when radiation incident on this snow, then most of the radiation is reflected. So albedo is more. But if radiation is on water, water has more absorption. So albedo is less, reflection is less in case of water. So suppose it is a sea and this is the ice and remaining is water. Suppose remaining is water, and if we talk about the reflection, so this is the ice. So from this reflection will be high, reflection will be high, but in case of water reflection will be less. So in case of water, most of the energy, most of the radiation is absorbed and reflection is less. But ice and snow, fresh snow is white. White, smooth and shiny surface always reflect the radiation, while the rough surface and dark surface absorb the radiation. And because radiation is absorbed, so less amount is reflected. So rough surface, dark surface, and the other properties of the material decide the absorption. So reflection is reduced if absorption is more. So in case of snow and ice, reflection is more, that's why high albedo. But if ocean is there, river are there, then reflection will be less. So this is the reason that moist soil have lower albedo than dry soil. So if soil is moist, soil is irrigated, then water content is more, so this water will absorb more radiation, so reflection will be less. So this is the reason that moist soil have less albedo than the dry soil. Similarly, if color is dark green or dark blue, otherwise overall black color has the maximum absorption and reflectivity is the least. But if we compare with the suppose green color, maybe light green color, medium green color or dark green color, as the darkness increases, absorption increases and reflectivity decreases. So this is the reason that dark color have low albedo. So we compare with the white and black. So black color substance will absorb the more radiation and reflection will be less. And in case of white color, reflection will be high. So albedo will be high. इसी तरह से अगर हम देखें, if we talk about the surface, if surface is smooth, and then reflection will be high, and if surface is rough, then reflection will be less. So this is the reason that how albedo affected. So if there is a yellow plant and some place green plants, so yellow plants will have more reflection. So yellow plants will show more reflectivity, more albedo, while green plants will show less albedo as compared to green plants. So as the plant's color change from green to yellow or dryness, albedo increases. So if there is a green color, then it will absorb the light and reflection will be less. So this depend upon the type of the crop, etc. So means the dark color is responsible for the reflection and albedo. So there are some reasoning related to radiation and the albedo. Thank you very much.